So here's where we left off last time when we talked about basic arrays. And again, the expectation is that my hope is you will have now be able to create an array as well as traverse through the objects in that array. What we're going to do today is look at some of the ways arrays are used because of this unique way that they're organized. Now, if you stick things in memory the way an array is, and does anybody remember what was special about the way an array is created? Yeah, so the syntax is using the square brackets. So this is an integer array. It tells Java to make an array. But what's special about the structure of an array? Physically, yeah.
It stores addresses.
It's going to store addresses, but physically in the computer, yeah, consecutive, right. So what we want to be able to do is manipulate that property, and I'll show you why it's powerful as far as using this idea of consecutive memory. One of the problems with consecutive memory is it will start to pollute the computer's memory. So if you abuse this, you're going to end up fragmenting. So anybody know that defrag utility that you run in Windows? Well, this is trying to undo what happens on the hard disk when you have too many big chunks of memory. It basically leaves your hard disk full of, I guess we call them like a virtual hole. But that's what happens with an array is if you make it too big, you start to pollute the memory. You actually start to lose performance. But for us, I'll just give you a quick idea of how we do this. So let's take a look at a method. I'm going to call it number. Oops. Sorry about that. And what I'm going to do here is my method's going to take in the integer form and spit back the string form. So it's like a translating function. It's a very basic example, but it's just to give you the simplest form of where arrays can be quite useful. So for example, previously we would have done something like this. And at this point, you should be bored, if you're not already. Right? You'd have to keep doing this. You'd have so many of these statements. It'd be fairly limiting, right? And if you think about the time that takes the computer, if you were to take the number like, I don't know, let's just say that we were crazy and we did this to 1,000,000. If we did that all the way to 1,000,000, it would take possibly 1,000,000 decisions to figure out that translation. But the alternative now, and I'll just comment it out so you can still see it, is to take advantage of the way that the array is created. I don't know why I keep jumping to the top, but got bad typing skills this morning. Is to take advantage of the way the array is built and stick the values we're looking for in an order that we can just retrieve what we're looking for. So what I'm going to do is I'm going to call this a string array translated, and I can initialize them like this. So I'll just do the numbers to 9. But now I can tell Java how to locate what I want. I can just say, now go to that index that you gave me and return the translated form. There is no decision to make here because of the way the array is organized. It's like I'm able to just jump right to the answer. If you give me the number 1, it will jump right here to index 1 and return that string. Okay? So again, the power here is now I don't need to make decisions. This technique is sometimes called indexing, but usually known as hashing. In the discipline for computing science, a hash function is one that allows you to look something up like that. So this is a really basic hash function where the index matches the translated value, so it goes right there. And you could probably do a PhD on studying how to hash things well. But this gain of speed is something that we would want to manipulate sometimes, where we recognize, hey, rather than looking things up, I can just make a table and grab the value out of this table. And one way it's done is with an array. So I can show you down here in my code. Let's just print one of these things. So give me the number for 7. So Java will run this. It'll look at my array. It will grab whoever's at index 7, which happens to be 7. So I didn't have to do an if-else statement, and I'm able to grab my data right away. So this is one of the big advantages of an array, is we can avoid this if-else statement. Even if we had a loop where we were traversing the elements in the array, looking for the spot, that still takes a lot of cost. This is no cost. This basically comes directly. So this comes with a constant complexity. It does not grow depending on how many items we stick in there. So this hashing, if you think about it, it's all around you. Just a second here. Don't show this message again. Thank you. It's all around you. How many of you guys have a social insurance number? Good for you. You're all paying your taxes then. But a social, well, maybe you haven't had the opportunity to pay tax yet. A social insurance number is one way that the government of Canada can find you quickly. You can imagine that having to manage those 30 million people, every time somebody needs to find something, it could be expensive, because how do they find you out of 30 million people, or 35? I'm not sure exactly where we're at nowadays, but one way they find you quickly is through your social insurance number. So that they may have some sort of hash function that looks you up very quickly. So that way when you call Canada Revenue Agency and you have questions and things, that's what they'll ask you for, because that's how they can look you up. Everybody here is uniquely identified by something else at our school. What do you have? A student number. That's how the school keeps track of you, right? How about in our province? Do you know there's another way that you can kept track of? Anybody had to send their transcripts away yet?
Pen number.
A pen number, yeah, personal education number. So again, these are all hash functions, but nobody says, what's your hash function for your provincial education? Nobody says that, right? They just say, what's your pen number? But this technique is everywhere because it's so fast. Now, the other technique we're going to take a look at, and we'll talk about how we can build some things here, but the other technique we're going to look at is parallel arrays. So for example, what I'm going to do is I'm going to create a little class for you. So we're going to go into my arrays thing here. And I'm going to create a new file. And I'm not going to pick the most creative example here. It's just something, again, that's simple that'll hopefully give you the idea of what I'm going to build. And I'm going to build a pet shop for you. And I'm going to make use now of several of these concepts. And what this pet shop is going to do is it's going to tell me about some of the animals at the store. Okay? So when I build this pet shop, I'm going to want to know how much space I have. Okay? So now the reason I'm going to do that is I will tell you what kind of animals that I have. Okay? So I'm going to create an array here. And now I'll know how many types of animals I have. Okay. So I'm going to make use of this this idea, and what I'm going to allow people to do in my pet shop is I'm going to allow them to set the type of animal. So you give me an index and the type of animal, and what I'll do is I'll go into my array and set that to be whatever you've given me. So I might tell you, please set the animals in the first slot to be dogs. All right, please set the animals in the second slot to be cats. Okay. And one other thing that comes to mind in this pet shop is they would have prices. there's going to be some cost associated with the animals. So one way I could organize this data, and again, this is very oversimplistic. This is probably not the best designed one, but one to show you how this technique is used, is I'm going to now store the information about cost. And for each animal, there's going to be a cost. So I'm going to go here and say, give me a new array of doubles. So I'll also allow you to set the price. So one way I can organize my data, we call these parallel arrays. And what I'm going to do is match the indices of the type of animal with the price of the animal. So if you tell me that dogs live in the first index, I'm going to put the type dog there at index 0, and I'm also going to put the price at index 0. So that way, if anybody's asking about dogs, they're all located in the same slots of the array. So I will retrieve this information if you give me that index. And what I'll do is say the animal at is a, and then I'll tell you what the type was. And then I'm going to tell you how much it cost. So again, all I'm using here is I'm organizing my data, and the technique is called parallel arrays, because I'm going to go and run this code and show you what it looks like, and it'll give you a better idea where it gets the word parallel from. But if I use the same index to represent dogs, then the type will be in that one index, and its cost will be in the same index. I could keep adding to this, like how long does this pet live? How much food does it eat? I could keep adding new arrays where everything to do with dogs is in the first slot for dogs. So we're going to go back here now, and in main, I'm going to create a pet shop. And let's just say that I have 10 pets here. So I will say now that my shop, please set the type at dogs to be dogs. And I don't know how much dogs cost nowadays, but I'm going to guess that dogs are probably, I don't know, let's say at least $250. And now I'm going to ask the shop to tell me what's happening at the dogs index, the space where all the dogs data is stored. So from that one index, I've got all of that data associated to it. When I run it, it says the animal at 0 is a dogs. So I guess I need to grammatically change that. And it costs $250. So the reason it gets this name parallel is what I'm doing with my data would look like this. Here's my array, and right now what I've done is put dogs. You know, maybe I'm going to have cats, goldfish, gerbils, and I've said dogs are $250, And nobody ever wants a cat, so might as well put 0. I'm just kidding. I'm obviously a dog person, but let's say, I don't know, cat's probably about the same cost. Goldfish is probably like $5. And gerbils, I don't know, let's say 50. But the reason it gets the name parallel here is dogs 250, cats 200. The indices line up, and that's where the term parallel comes from. Okay? So, those are our 2 techniques. I'm going to let you guys take a look at some of the basic exercises. But again, what we need to be able to talk about in our course is how to use this technique of indexing, as well as how to store data in a parallel array.